Hi, this video is for my Calculus 1, and this is what we did in class for practice. So everybody just wrote these in their spiral notebook because I want to do some indefinite integral practice and having you practice with your antiderivatives. So part of this is I want you to follow through with me. I know we've practiced antiderivatives, but I want you to be careful of the notation. So when I first start this one right here, I realize that I'm going to have to distribute to get this in a form that I can do the antiderivatives for. So when I do that, I'm going to say equals the integral of x cubed plus 3x dx, okay? Once you write it like that, and I cannot evaluate it because it's indefinite, it's not a definite integral, so I'm just going to do the antiderivative. So when I add one and multiply by the reciprocal, I get 1/4 x to the fourth plus add 1 and multiply by the reciprocal, so I have 3/2 x squared, and don't forget your constant c. So anytime you have an indefinite integral, you're going to actually make sure you put your constant c because we don't know what that is. So that was the first one we did in class. Now you can stop this anytime, see if you can do it by yourself, and then see how we do it. So here's the second one. Integrate the following, okay? So when I did this one, I thought I have to write this in a method, and I'm going to show you an alternate one too, so that I can figure out how to do this. So I'm going to rewrite it, and I'm going to do it baby steps. So basically, this is going to be, ready, 3/2 to the -2 dx, which equals the integral, ready, of 3 to the -2 x to the -2 dx. I'm just going really slow, which is the integral of 1/3 squared, or 1/9, okay? And this is x to the -2. I don't know why I got rid of that -2 right here. So let's fix that. Okay, so I can write it as 1/9 x squared, or 1/9 x to the -2, okay, dx. So now it's in a method that I can go ahead and do the antiderivative. So it's going to equal, so I'm going to add 1, multiply by the reciprocal. You're going to get -1/9 x to the -1 plus c, or you can write it as -1/9x plus c. Either one is fine. Now, I'm going to change this up a little bit. And what if I got rid of the 2 and I just had this, the integral of 1/3x dx? You're like, oh, that's going to be the same thing. Well, let's try it. So I have 1/3x. So now that we know how to write this, I can say that's the same as saying the integral of 1/3 x to the -1 dx. But then when I go to add 1, I get an x to the 0. If that happens, then that's natural log. So this is really 1/3 the natural log of x plus c. And I just wanted to show you that sometimes when you get started, you don't know what you're working with, and you write it this way, and you're like, okay, I'm going to add 1 and multiply by the reciprocal, and when you get a 0, then that will be natural log. So I just wanted to do that one with you as well. All right, let's try another one. Integrate the following. Now I have to get this in a method that I can do the antiderivative and integrate it. So it's going to be the integral, and when I do this, I'm going to divide everything by x to the fourth and rewrite it. So that's going to be the integral of x to the -2, because there's 2 more in the denominator, okay, plus 2x to the -3 minus 3x to the -4 dx, okay? Now I'm going to go through and do the antiderivative. So I'm going to add 1, multiply by the reciprocal, so I get -x to the -1 minus x to the -2 plus x to the -3 plus c. Or I can write it as this, -1/x minus 1/x squared plus 1/x cubed plus c 3. They're both the same, but I just wanted to show you that you could write it either way. Okay? Now it says solve this initial value problem. So I have the slope, dy dx is 9x squared minus 4x plus 5, and they told us y of negative 1 equals 0. So that is the original function. So I'm going to go through and do the antiderivative of here. So I have y is going to be add 1, do the antiderivatives, is 3x cubed minus add 1 multiplied by the reciprocal, negative 2x squared plus 5x plus c. Now this information right here actually helps us. So if I do y to the negative 1 and I know it equals 0, then I can actually figure out what c is, and which is really just a point on the original graph. So I'm plugging negative 1 wherever there's an x, putting it equal to 0. So when I do this right here, I get a negative 3, and this is a 1, so that's a negative 2 because that's positive 1 times a negative 2 minus 5 plus c equals 0. And when I put all these together, I get a negative 10, and I move it to the other side, so c is 10. So my y function is really y equals 3x cubed minus 2x squared plus 5x plus 10. So there's my original function. Now this one I did in class. I could literally hear kind of everybody groan because there's trig functions in there. And so they did dv/dt, and they told me what v is, so I'm going to do the antiderivative. So the first one was okay, add 1 multiplied by the reciprocal, so I got 4t squared. But then everybody kind of pauses, and they had to look at their derivative card, which is fine. So that's going to be negative the cotan of t. I don't like those two t's together, so I can put that in parentheses, plus c. So make sure you know your antiderivatives of your trig functions. Now we're going to plug in v of pi over 2. So that's 4 times pi over 2 squared minus the cotan of pi over 2 plus c, and they said it equals negative 7. So I go here and I'm going to take this in baby steps. So this is pi squared over 4. The 4 cancels out, so that's just pi squared minus, now the cotan of pi over 2. Well, if you do the tan of pi over 2, I know it's undefined, which means it's divided by 0. So if I do the reciprocal of that, that's just going to be 0 plus c equals negative 7. So when I solve for c, I have c equals negative 7 minus pi squared, which is a constant. I know it's not pretty. So v is going to be 4t squared minus the cotan of t minus 7 minus pi squared. That is my original function. So I hope this helped a little bit, and I'll see you in class.